A particle is at the point with position vector 10j relative to O. It is projected with velocity 10I meters per second. We want to find the position vector of the particle 1 second later. Here is our particle at the position 10j, which means the distance from O is 10. If it's projected with velocity 10I, then it's projected horizontally with a speed of 10 meters per second. Gravity acts vertically downwards at 9.8 meters per second squared. The position vector, we need both horizontal and vertical. Considering horizontal first, remember just S, U and T. We want to know S, U is 10, and after 1 second, so T is 1. It follows that the horizontal distance is U times T, which is 10 times 1, or 10 meters. Now to collect the vertical information, remember using SUVAT. Taking downwards as positive means that A is positive 9.8 meters per second squared. The time we know is 1 second. The distance we want to know, and since projection is horizontal, U, the vertical velocity initially, is 0 meters per second. We can use S equals ut plus a half at squared. S is going to be 0 plus a half times the acceleration times the time squared, and this gives us 4.9 meters. This 4.9 represents the distance fallen. It started 10 meters above the ground, so it will now be 5.1 meters above the ground. The position vector of the particle then is 10I and 5.1 meters above the ground, so 5.1 j meters. We now want to know the speed of the particle after 1 second. Horizontally there's no acceleration, so the speed will still be 10. We can work out the vertical speed using our SUVAT information, and we could use V equals U plus AT. So V is 0 plus 9.8 times 1, giving 9.8 meters per second. So the particle has a horizontal component of speed of 10 and a vertical component of speed of 9.8 downwards. The speed of the particle will be v. We can use Pythagoras' theorem. So v squared is going to be 10 squared plus 9.8 squared, and v will therefore be the square root of 10 squared plus 9.8 squared. And this comes to 14.0 meters per second, correct to 3 significant figures. We now want to know the position vector of the point where the particle lands on the horizontal through O. In other words, it falls down. We want the coordinates, or the position vector, of this point. We know that it started 10 meters above the ground, and the projection was horizontal at 10 meters per second. The acceleration acts downwards and is 9.8 meters per second squared. We need to find first the time at which it lands. So first, considering vertical motion, it lands when it has fallen by 10 meters. The initial vertical speed we know is 0. The acceleration is 9.8 meters per second squared, and we want t. We can use s equals ut plus a half at squared, and then 10 is equal to 0, since u is 0, plus a half times 9.8 times t squared. So 10 is equal to 4.9 t squared, giving us t squared is 10 divided by 4.9. This is 100 over 49, and so t, being the square root, is 10 over 7 seconds, giving an exact answer. Of course, there's no reason why you couldn't give a calculator answer. Now considering the horizontal motion, remember just s, u and t. We want the horizontal distance. We know the initial speed was 10, and the time we now know is 10 over 7 seconds. S is 10 times 10 over 7, which is 100 over 7 meters. We want the position vector of this point. The coordinates we know are 100 over 7, 0, so the position vector will be 100 over 7i and no j's.